In the name of Allah, the Compassionate and the Merciful. Hello guys. In this video, we're going to solve the nonlinear connection problem. As you see, you see in this picture, we have one rigid element and two actual spring, which is defined with K1 and K2. K1 and K2, it has a stress strain relation and in each spring, and you see that two applied load is defined in here. You can change it with your own. And K2, it has u displacement from rigid element, and in our analysis actually we are going to apply incremental displacement in this direction, and in each increment we are going to solve the stiffness matrix of K1 and K2. And K2, if the displacement reach to this from this to this, so the K2 is included in our analysis. So at first K2 is not indicated in our analysis. So and in each step we're going to calculate and output our base shear and displacement for our pushover analysis. So you see that in our analysis we use very simple example, but it has very complex calculation of checking a step-by-step process of our analysis. So let's see in here. Let's see in our code. Yes, in here I used C programming for solving this example. I used many functions in here. You see that for inputting our datas in data 1 and data 2. Data 2 function is used for defining the strain and stress relation of each spring. And let's see in data 1, you see that we defined length of rigid elements, spring length of spring 1 and spring 2, spring areas. You see that the external applied load in spring 1 and 2, you see that, and incremental distance of spring 1 from rigid element, you see that, I mean this. Okay, and let's see the other one. Yes, and ultimate absolute displacement, you see that it checks for our last step of analysis and number of increments. And let's see the stress relation of the each spring, which is imported from CSV file. From this file you can change it with your own, and actually the length of each spring you can change it with your own in here. So, and after running the analysis in analysis report, as you see, in each increment base shear and displacement is calculated. And you see that, let's see, in yes, in increment 2000 increment displacement reached to ultimate displacement. So we are going to so the analysis is stopped because of this ultimate displacement. So we're going to output in Excel and MATLAB file. So let's see the output file in MATLAB or Excel. Let's see in Excel file. You see that we output our Excel file, in CSV file. In CSV file, you see that base shear and displacement is in each steps is shown, and you see that if we graph it, you see that relation between base shear and displacement of this rigid element with two spring, and as I told you before, that two springs is nonlinear of geometric, and material of these two spring is indicated in our analysis. You see that in displacement 2000, suddenly we are going to we're going to stop the analysis because it reached the ultimate, and let's see, spring reached to this one and this, and in here suddenly we are going to have an zero stiffness in here steps. You see that incremental displacement applied in here, and each step actually we have a curve relation displacement of this, not vertical displacement. You see that in displacement is changed from here, like curve comes here. So in here analysis is going to be stopped in here because we used geometrical nonlinearity of our spring and in our analysis, and nonlinearity behavior of stress relation of these materials of spring. You see that it is very complex to be calculated, but it is very simple example. You see that in here, and if I input our all data in analysis function, you see that I use the incremental in here, for example, z equals to 1 to m, and in each increment of displacement in here, you see that all base shear and displacement are calculated, and it is going to be output in Excel and MATLAB file for better showing and better displaying of this analysis. And I used many functions for checking of my analysis. So thanks a lot, guys. I'd be glad to know about your opinions about my programming of this kind of modeling of these structures. Thanks a lot, guys. Bye.